supposed to find the derivative for this problem. We can't do it in its current form because it's a fraction. If there's more than one term in the numerator and it's a fraction, then we don't know how to find the derivative. We can change it. We could write this as 4x to the 6th divided by 20 minus 5x squared divided by 20 plus 9 divided by 20. That reduces to 1/5 x to the 6th minus 1/4 x squared plus 9/20. This is the original function. Therefore, f prime, take the 6 times 1/5, which is 6/5, subtract 1 from the exponent. I take 2 times a 4th, which is 1/2, subtract 1 from the exponent. The derivative of a constant, 9/20, is just 0. Therefore, f prime of x, 6/5 x to the 5th minus 1/2 x. Number 2 is similar in that it is in a form that we don't know how to find the derivative. So we change the form. The square root of x is the same thing as saying x to the 1/2. The cubed root of x squared is the same as saying x to the 2/3. And x, the 4th root of x to the 5th, is the same as x to the 5/4. Notice the root is what the denominator is, and what was the exponent is the numerator. That's how that works. So now that it's in this form, you can easily find the derivative. Multiply the exponent by the coefficient. Half of 4 is 2. Subtract 1 from the exponent. 1/2 minus 1 is a negative 1/2. And then 2/3 times 6. You multiply the 6 times the 2 and divide by 3. Or you can divide the 6 by 3, then multiply by 2. Whatever you do, you're going to get the same result. 6 divided by 3 is 2. 2 times 2 is 4. Or 6 times 2 is 12, divided by 3, 4. Subtract 1 from the exponent. 2/3 minus 1, or minus 3/3, is a negative 1/3. 5/4 times 4 is 5. Subtract 1 from the exponent, and you get 1/4. Number 3, find the x and y-intercepts. Let's do the y-intercept first, because that's generally simple. Simply replace the x values with 0. And we get the y-intercept is negative 3. To find the x-intercepts, plural or singular, depends on the problem, replace y with 0 and factor. You don't always factor, but if the problem looks like this, you're going to have to factor. So trinomial. First thing you try to figure out, is it a perfect square trinomial? It's not, because the first term is not a perfect square. Then, if the lead coefficient is anything other than 1, you need to split the middle term and factor by grouping. So the first term and the last term stay the same. The middle term, 5x, gets split into 2 different terms. Figure out how it splits. You need 2 things that multiply to get a times c. Those same 2 things add to get b. A is 2, c is negative 3. So that's multiply to get negative 6. B is 5. So multiply to get negative 6, such as positive 6 and negative 1. Add to get 5. 6 plus negative 1 is 5. So on one of these blanks you put a 6, the other one you put a -1. It's important that you have this plus sign between these terms. It will cause you major problems if you don't. Once you've split the middle term, then you factor by grouping. To do that, you simply group terms together that have common factors. Make sure that you leave a plus sign between your parentheses. That is oh so important. It's wrong if you don't. Find the GCF of each group. GCF of this is 2x. GCF of this over here is -1. GCF of these two groups, of these two terms, is x plus 3. What's left from this first term is a 2x. What's left from the second term is a plus -1, or just a subtract 1. Then you take each factor, set it equal to 0. So we have x plus 3 equals 0. 2x minus 1 equals 0. Here we get x equals -3, and here we're going to get x is 1/2. X-intercepts, 1/2, -3. Number 4, Y-intercept. Simple. Simply replace the x values with 0. And you get f of 0 is 21. X-intercept, singular or plural. Replace y with 0. We're going to have to factor this problem. GCF is a 1, so ignore that step. It's not a perfect square trinomial. The first term is a perfect square, but the last one isn't. If the lead coefficient is a 1, which it is here, this is the easy type to factor. You just need two numbers that multiply to get 21 and add to get -10, such as -3 and -7. Set each factor equal to 0. Solve each of those little equations. And you get x is 3 and x is 7. Find the critical points for the function, then determine the nature of the critical points. To find critical points, you first need critical values. To do that, take the first derivative, set it equal to 0. Solve it. We're going to have to factor this. We're going to have to split the middle term and factor by grouping. So how does this split? We need two numbers that multiply to get a times c. It's 3 times -1. Two numbers that add to get b. That's 2. So that will work here. How about a +3 and a -1? That works for both of these. So on one of these blanks, you put a +3. The other one you put a -1. It's important that you have this plus sign between. That's splitting the middle term. Then you group terms together and have common factors. 3x squared plus 3x, common factors, plus -x minus 1, have common factors. Find the GCF of each group. This is called factoring by grouping. Factor a -1 out of this. So we get two terms, this term and this term. What's the GCF of those two terms? What do they both have in common? An x plus 1. What's left? 3x plus -1. or 3x minus 1. Take each factor and set it equal to 0. So at critical values of 1/3, -1. Hopefully you know just by looking at this, hopefully, what these points are going to be. Second step, find more critical values from the second derivative. If we solve this, we get -1/6 for another critical value. Step 3, find critical points by taking the critical values and plugging them into the original function. Put them in ascending order from smallest to greatest. Put a -1 into your calculator into this function, you're going to get a 1. If you put a -1/6, you're going to get approximately -0.185. If you put a third in, you're going to get approximately, pardon me, I wrote down the wrong number. That's for 1/3. For -1/6, it's 0.190. These are approximations. So we got critical points of -1,1, -1/6, 0.190, and 1/3, -0.185. We have to determine what kind of critical points these are. So comparing with this -1,1, I need to pick test values to the left and to the right of that. So to the left of -1, like -2, between -1 and -1/6, between -1/6 and 1/3. This is 0 we could use, here we could use 1. Here we could use -0.5. So we got to figure out what f of -2 is, f of -0.5, f of -0.5, f of 0. These groups, this group of numbers are comparing to this. And then lastly, f of 0 and f of 1. For this, we're comparing these numbers to the green ordered pair you see there. If I throw these into my calculator, real quick, we get -2, 0.625, 0.625, 0, 0, 1. I apologize for my lack of space. Let me make this a little smaller so I can have some more room here. Comparing this -2 to this 1, it's below. 0.625 is also below 1. Since those are both below, that makes this a maximum at -1, 1. 0.625, I'm comparing to 0.190. This is above. 0 is below. If some of your points are above and some are below, then it's an inflection point. And then down here, comparing the 0 and the 1 to the negative 0.185. 0 is above it. 1 is above it. That's a minimum. So our maximum is negative 1, 1. Inflection point is negative 1/6.190. Minimum is 1/3, negative 0.185. Once again, you should know this without doing any of this work, although I am requiring you to show this work. Looking at this original function, you should know that its parent graph is y equals x cubed, which looks like this. As long as the lead coefficient is positive, it's going to have this general shape, whereas the left it goes down, and on the right it goes up. When you throw in other terms here that have x's in them, you're essentially grabbing a hold here and here and pulling this apart so that this graph looks like this. From left to right, what happens first? Maximum, inflection point, and then minimum. It's not a coincidence. Number 6, we got to find some critical values. To do so, we take the first derivative. 5 times a fifth is 1. Subtract 1 from the exponent. 441 times 1 is 441. You get x to the 0, which is 1. Set this equal to 0. This is the difference of two squares. The square root of x to the 4th is x squared. The square root of 441 is 21. So you end up with this fine mess. Difference of two squares. X squared minus 21 and x squared plus 21. Set each factor equal to 0. Solve each of these. Here we're going to get plus or minus the square root of 21, which is approximately 4.58. Here we're going to get the square root of a negative number, which is imaginary. We don't concern ourselves with the imaginary ones. Imaginary. So we get critical value of plus or minus square root of 21, which is approximately 4.58 plus or minus. Step 2, find more critical values. Take the second derivative. This would be 4x cubed minus 0. Set it equal to 0. And we end up with critical value of 0. We have 3 critical values, 3 critical points. By the way, you should know, since this is x to the 5th, which is similar to x cubed, and the leading coefficient is positive, your first critical point is going to be a maximum. Your second one is going to be an inflection point, and your third one is going to be a minimum. Let's confirm that. I list these from smallest to greatest. If I put this into my calculator, this is approximately 1,600, 100, 1616.73. 0 in gives me 0. Square root of 21 gives me a negative 1616.73. So I have these critical points. So when I pick these test points for this, I need something to the left, between, and to the right. Remember, this is about negative 4.5 something, so let's go negative 5. Between negative 5 and 0, let's say negative 1. Between 0 and 4.5 something, let's say 1. And then to the right of 4 point something, let's say 5. And once again, this took up too much space. So step 4, I need to look at these test points. Got these all crammed together, which is not good. Let me color code to simulate non-cramming. So let's put these into f of negative 5 is 1580, negative 1 is 440.8, f of 1 is negative 440.8. F of 5 is a negative 1580. Comparing these two numbers with 1616. These are both below. Comparing these numbers to 0. We got one above. We got one below. Comparing these numbers to negative 1660. These are both above. Got points below, we got a maximum. We got some above and some below, we have an inflection point. We got points on both sides that are above, that must mean this one is pretty low. Throw your answers into the right boxes and you're finished. Number 7. Position of a particle with respect to time can be described by this function where f of t is in meters, t is in seconds. Find the instantaneous velocity in meters per second. Instantaneous velocity means derivative. So we find f prime, that would be 6t plus 5. It says find this when t is 4.29. Using a calculator, 6 times 4.29 is 25.74. Add 5 to that. Label this answer. When you label this, it's real easy. This is a slope. Remember, when you have slope, you have the change in y's over the change in x's. Y's have a label, x's have a change or have a label. Our y's here are in meters. Our x's are in seconds. So when you label this, it's 30.74 meters per second. Meters per second. F is in meters, t is in seconds. The acceleration of the particle in meters per second squared can be found by finding the second derivative. That's the derivative of the derivative. That's 6. Find the acceleration of the particle. It's 6. How do you label it? Well, this is f double prime. So basically, this is the slope. So we have f prime on the top, and we have t on the bottom. F is measured in meters per second. We figured that out. T is measured in seconds. That's why this says here meters per second squared. To fix this complex fraction, you multiply by the reciprocal, and you're multiplying s times s, you get s squared. 6 meters per second squared. One of the most spectacular long jumps ever performed was by Bob Beamon in the '68 Olympics. His jump, 29 feet, 22.5 inches, surpassed the world record by 2 feet. The function, h of t equals this. Describe the height of the jump in meters with respect to time in seconds. What was the maximum height of the jump? It's asking you to find the maximum. To do that, you find the derivative. Set it equal to 0. And you get about 4.47. It asks for the maximum height. T is in seconds. Now, this is a critical value, this t. How do we know this critical value is height? This is a parabola. Its t squared is the biggest exponent, and it's negative. If it's negative, that means this opens down, which means this critical point has to be a maximum. So this is the seconds. It asks for the height. Seconds does not measure height. To figure out what the height is, you put 0.47 into the original function. Made a mistake here. I wrote 4.7, but it's supposed to be 0.47. Which makes this 0.2209, which changes this dramatically. So So we get 2.162 minus 1.08241. Which gives us 1.08 approximately. This is h. H was measured in meters. That's the y value of the critical point. So the maximum height is 1.08 meters. How much time in seconds did Bob spend in the air on his jump? Well, this is basically asking us for the X-intercepts or the T-intercepts. To find that, you simply take our function, set it equal to 0, and factor it. Set each factor equal to 0. This one's already solved. T is 0. Here, if we add 4.9 to both sides, 4.9t, divide both sides by 4.9, you get t is about 0.94. So how is it that when the height is 0, we have a time of 0 and a time of 0.94? Simple. This dude's running. Height is how high he is. So when he first jumps at time 0, his height's 0. Then he's going to be in the air. He's going to be in the air until his height returns to 0. At that point, it is 0.94 seconds later. So his time in the air will be 0.94, subtract 0, and you get 0.94 seconds. And finally, you're supposed to graph this function, which is pretty simple because we found the X-intercepts 0 and 0.94. This is the time. This is measured in meters. And we have this maximum, which not coincidentally is halfway between. 0.47 seconds got us 1.08 meters high. So that's your graph. Number 9, we have this open aquarium. Has a volume 363 cubic feet. What are the dimensions of a rectangular base? This base is a rectangle. We'll call this length and width. We'll call this the height. When you write variables, you need to define them. L is the length. W is width. And I should say here that V is volume. What are the dimensions that will minimize the material? Material means the surface area. So we need a material function also known as surface area. So this is step 1, defining your variables. Also, we were told that the height is 3 feet. So, material, or surface area. I need to find the area of the front, area of the back, area of the left side, area of the right side, and the area of the bottom. There's no top. It says it's an open aquarium. Using an A here, so I need to say A is area. The front is L by 3. The back is also L by 3. The left side over here is 3 by W. The right side is also 3 by W. The bottom is L times W. If I simplify this, I get this. I'm supposed to minimize this. So to do that, I have to find the derivative. I can't find the derivative because this is in two variables. So I'm going to use the volume formula. Volume is the area of the base times the height. Our base is a rectangle, length times width, and our height is 6, we're told. And we're told the volume is 363 cubic feet. If I divide both sides by 6, then get W by itself, I get that W is 121 divided by L. I'm going to take this and substitute this, replacing all of my W's with 121 divided by L. Simplify this. 6 times 121, 726. This L, we're dividing by it. We could write this as L to the negative 1, which is what we want to do because we got to find the derivative. Here your L's cancel, so you get plus 121. This is our official material function. Next thing we got to do is find the derivative. That would be 6 minus 726 L to negative 2. A negative 1 minus 1 is a negative 2. The derivative of 121 is 0. Set it equal to 0. I'm going to multiply each term by L squared. This is going to get rid of the fact that I have a negative exponent. 0 times L squared is 0. 6 times L squared is 6L squared. L to the negative 2 times L squared, those cancel. They're inverse operations. Add 726 to both sides. Divide both sides by 6. Square root both sides, we get plus or minus 11 for L. Could be plus 11, could be negative 11. Negative 11 for the length is ridiculous. And I can't spell that, so I'm not going to say that. Is dumbness. So the length is positive 11. And this was talking about feet, I believe. So what is the width? So 121 divided by 11, which is 11. Be a good idea to confirm that this is minimum, but I'm not going to trick you on these word problems. When you get critical points from the first derivative, it's always going to be what it is it's supposed to be. Dimensions of the rectangular base. The rectangular base is 11 feet by 11 feet.